This is question number 21 on the final exam review for trigonometry. Establish the identity. Before I look at the problem, I just want you to know if it says establish the identity, the goal is to make one side look like the other side. And to do that, you need to know some substitution in terms of the fundamental identities or algebra. So with this one, I'm looking at it, and the left-hand side, which is 1 minus secant theta over tangent theta, plus tangent theta over 1 minus secant theta, looks much harder than the right-hand side, which is negative 2 cosecant theta. So I'm going to always work on the harder side because there's probably more that I can do with it so that I can manipulate it through the use of algebra and the fundamental identities so it looks like the right-hand side. So when I look at this, I think what we should do is find a common denominator. So the least common denominator of this is going to be tangent theta times 1 minus secant theta. My next step is to build up both of these values here so that my denominator says tangent theta times 1 minus secant theta. Okay? So in if you look at the numerator of the first one, I had 1 minus secant theta. So I had tangent theta in the denominator. Now I have tangent theta times 1 minus secant theta. So what you do to the denominator, you have to do to the numerator as well. So now I have 1 minus secant theta times 1 minus secant theta. In the second one, I had 1 minus secant theta in the denominator. I now have tangent theta times 1 minus secant theta. So I have to multiply the numerator by tangent theta as well. So I had tangent theta before, I'm multiplying it by tangent theta. So this is what I have right at this moment. Okay, since my denominators are the same, now I can go ahead and FOIL or distribute 1 minus secant theta to 1 minus secant theta. So when I do that, the result is 1 minus 2 secant theta plus secant squared theta. And tangent theta times tangent theta is tangent squared theta. And this is all over tangent theta times 1 minus secant theta. Okay, if you look, this really doesn't look like the right-hand side yet. And I'm looking at this and I can't simplify or add like terms in the numerator. So when you have squared terms like secant squared or tangent squared, I'm going to rely on Pythagorean identities. So the Pythagorean identity that I'm interested in is the one that links up tangent squared and secant squared. So if you remember, we said tangent squared theta plus 1 equals secant squared theta. That is a Pythagorean identity. Okay, if I manipulate it and get tangent squared theta by itself, I get secant squared theta minus 1. So I'm going to use this substitution. Wherever I see tangent squared theta, I am going to write secant squared theta minus 1. So now I have 1 minus 2 secant theta plus secant squared theta. Now instead of having tangent squared theta, I have secant squared theta minus 1. And this is all over tangent theta times 1 minus secant theta. Okay, at this point, now I can start getting rid of some things and combining some like terms. If you look here, you'll notice that the 1's will cancel each other out. 1 minus 1 is 0. And I have two values that are the same, secant theta and secant squared theta. So these two are the same, so I can add those together. So when I do that, I get negative 2 secant theta plus 2 secant squared theta all over tangent theta times 1 minus secant theta. Okay, so I'm going to work with that, and I'm going to factor out or take the greatest common factor out of the numerator and see what happens. Okay, so the GCF of this, I'm going to actually take out a negative 2 secant theta. If I factor that out, I'm left with 1 minus secant theta. And the whole reason for factoring out the greatest common factor was because our denominator is tangent theta times 1 minus secant theta. If you notice, the binomials, 1 minus secant theta and 1 minus secant theta are exactly the same, and I'm able to cancel them out. So at this point, I now have negative 2 secant theta over tangent theta. Now, at this step, I'm going to rewrite secant theta and tangent theta in terms of sine and cosine. So we know secant theta is equivalent to 1 over cosine theta, and tangent theta is equivalent to sine theta over cosine theta. So I now have negative 2 times 1 over cosine theta, and remember, to turn this into a multiplication problem, I have to take the reciprocal of the denominator. So this becomes cosine theta over sine theta. Cancel out your cosine thetas, and you get negative 2 times 1 over sine theta. 1 over sine theta, by definition, is cosecant. So now we have negative 2 cosecant theta, and that is my right-hand side. And I'm putting a little square there to let me know that I've now just established that the left-hand side looks like the right-hand side. A quick note, if you start on a side, you never, ever, ever cross over to the other side. It is not solving an equation, it's establishing an identity. So whatever side you start on, you end on that side. Okay, that's it.